What is the true nature of the universe? To answer this question, humans come up with stories to describe the world. We test the stories and learn what to keep and what to throw away. But the more we learn, the more weird and complicated our stories become. Some of them so much so that it's really hard to know what they're actually about. Just like the string theory, a famous, controversial, and often misunderstood story about the nature of everything. Why did we come up with it? And is it correct? Or something we should chuck up? So today, let's dive deeply inside this ocean deep question. Want to join us on the journey to these mysteries of the universe? Then subscribe to our channel and also click on the bell icon for further new notifications. Watch the video till the end. Hope you enjoy watching this video. Then please give it a thumbs up and do share it with other keen learners like you. Now, let's get started. What makes string theory so elegant is that it describes many different elementary particles as different modes of vibration of the string. Just like a violin, string vibrating differently can give you a lot of different notes. A string can give you different particles. Most importantly, this includes gravity. String theory promised to unify all fundamental forces of the universe. This caused enormous excitement and hype. String theory quickly graduated to a possible theory of everything. Unfortunately, string theory comes with a lot of strings attached. Much of the maths involving a consistent string theory does not work in our universe with its 3 spatial and 1 temporal dimensions. String theory requires 10 dimensions to work out. So, string theorists did calculations in model universes and then tried to get rid of the 6 dimensions and describe our own universe. So far, nobody has succeeded, and no prediction of string theory has been proven in an experiment. So, string theory did not reveal the nature of our universe. One could argue in that case, string theory really isn't useful at all. It's all about experiments and predictions. If we can't do those, why should we bother with strings? It really is all about how we use it. Physics is based on maths. 2 plus 2 makes 4. This is true, no matter how you feel about it. And the maths in string theory does work out. That's why string theory is still useful. Imagine that you want to build a cruise ship, but you only have blueprints for a small rowing boat. There are plenty of differences. The engine, the materials, the scale. But both things are fundamentally the same. Things that float. So, by studying the rowing boat blueprints, you might still learn something about how to build a cruise ship eventually. With string theory, we can try to answer some questions about quantum gravity that have been puzzling physicists for decades, such as how black holes work or the information paradox. String theory may point us in the right direction. When used in this spirit, string theory becomes a precious tool for theoretical physicists and help them discover new aspects of the quantum world and some beautiful mathematics. So maybe the story of string theory is not the theory of everything, but just like the story of the point particle, it may be an extremely useful story. We don't yet know what the true nature of reality is, but we'll keep coming up with the stories and try to figure it out until one day, hopefully, we do know. That was all for today's video. We'll meet in the next video. Till then, take care of yourself and bye bye.